right, so let's see if we can't write formulas given names. So you'll need your periodic table and those oxidation numbers that we've talked about previously, okay? And then you can work through these and then pause and then check yourself if you'd like. All right, so if we look, and one thing you got to remember that in neutral compounds, the oxidation numbers cancel out. So if I have a +2, -2, they equal 0. And the subscripts multiply those oxidation numbers to make them equal 0. Okay, so you kind of have to use a little algebraic thinking to help you with this. All right, so if we look, we see that potassium is in group 1 and it has a +1 oxidation number. All right, so we know that it has a +1 oxidation number. Eventually, I'm going to get to where I can use this. I can't use this very well. So let's do that. No, I can't use that. Okay, forget it. So I know that potassium has a +1 oxidation number. All right, then we look at our periodic table and we see that sulfur, sulfide, comes from sulfur, which is in group 16, and it has a typical -2 oxidation number. All right, so we know that +1 - 2 does not equal 0. So that means I'm going to need 2 potassiums for every 1 sulfur to make this equal out to a neutral compound. So we have K2, oh, okay, let me try this again, 2S, whoops, potassium sulfide, K2S. All right, so let's try the next one. We see that we've got strontium, which is in group 2. So it has a +2 charge or oxidation number. We see that iodide is in group 17 and it has a -1 oxidation number. All right, so we know that 2 - 1 does not equal 0. All right, so we want those to cancel out. And in order for that to work, we're going to need to multiply and have 2 times the iodide atoms bonding with strontium, right? So we have SRI2 for strontium iodide. All right, so let's try aluminum. Aluminum is a group 13 metal, has a +3 charge. Sulfur, we already said that before, is a -2. So 3 - 2 does not cancel. So we're going to have to multiply them both. And 3 and 2 are common factors of 6. So that means I'm going to need 2 aluminums for every 3 sulfides, and then we end up with +6 - 6. So we need 2 aluminums for every 3 sulfides. So 6 - 6. You can also do this idea of this crisscross applesauce that I've seen, and you probably saw in the video in yesterday's lesson. So you just don't write the 1. You can take the oxidation number on the metal and bring it down and make it the subscript on the nonmetal. And you could take the oxidation number on the nonmetal and make it the subscript on the metal. Except notice you don't ever write the 1s. Okay, so you can always cross them most of the time, but then you have to think about, are they written in the lowest possible coefficients? Like, can you reduce them? Since we can't reduce 2 and 1 or 1 and 2 or 2 and 3, they are in the lowest possible factors of their subscripts. So we can't reduce them any further. Okay, so you can always do it that way if you have a hard time thinking in terms of like the metal, non-metal, what do I need to multiply by? You can just take the metal and make it the subscript on the non-metal, make it the subscript on the metal. Okay. All right, let's try this next one. We got calcium is in group 2, And bromide is from bromine, which is in group 17. So we've got 2 minus 1 does not equal 0. So we're going to need 2 bromides for every 1 calcium to make that a neutral compound. Again, you can take the oxidation on the metal, make it the subscript on the nonmetal, oxidation on the nonmetal, make it the subscript on the metal. All right, sodium's in group 1, has a +1 oxidation. Chloride comes from chlorine. It has a -1 oxidation. Oh, look at that. That makes a neutral compound. We're familiar with that. That's table salt. All right, so we got magnesium. It's a +2 in group 2. Whoops, a little thing is kind of not working out here. Okay, sulfide is in group 16, -2. Look at that, those cancel out. Now this is an example of if the crisscross method, you use that. So you'd have a 1 and a 1, and that you need to reduce those to the lowest common coefficient, subscript. Same thing here. If you wrote Mg2S2, you would need to divide everything by 2 and reduce that down to 1, which you don't write the 1s. Okay, so be careful if you are using the crisscross method. You still have to look at the formula and think, is it written in the lowest possible numbers for the subscripts? If not, reduce it down by dividing. Okay, so that's why I'm not crazy about the crisscross method for that reason, but you can use it. All right, so let's lithium +1, group 1. Hydride. What is the oxidation for hydrogen when combined with metals? -1. All right. And that is, I forgot to go back and do this little dude here. Hold on. Oh, baby. Okay. MgS. Okay, magnesium sulfide. All right, come back over here. And then we got LiH. All right. Aluminum is in group 13. It's a +3 metal. Phosphide is also, look at that, a -3 because it's in group 15. So we don't have to do anything. You could do crisscross, and then you have to reduce by dividing by 3. So LAP. All right, barium is in group 2. It's a +2 metal. Nitride is in group 15. It's a -3 non-metal. And then you can take the 2, make it a subscript on the nitrogen, take the 3, make it a subscript on the barium, and then you got 6 minus 6 equals 0. Barium nitride. All right, and then we got rubidium. Rubidium is in group 1. That's a +1 metal. Oxide comes from oxygen, is in group 16, is a group -2 non-metal. Okay, and again, drop the subscripts and the coefficients. So you're going to need 2 rubidiums for every 1 oxygen to make that a neutral compound. Rubidium oxide. And that, my friends, is how you write formulas given the names for simple binary ionic compounds. Notice this is only for group 1, group 2 non-metals, group 3 metals with non-metals. So it's a very small group of elements that we're talking about here. All right, talk to you later. Bye.